Welcome to GMST Davangere. I am Anil Kumar TRV, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the experiment number 4. So that is SCR town circuit using synchronized UJT triggering. Aim to trigger the given SCR operating on AC supply using UJT relaxation oscillator in synchronous mode. Theory. So UJT works on satisfactory relaxation oscillator. Output pulses of variable time periods are possible by suitable increase in the emitter to base voltage from a very low voltage level to the peak voltage level, either by employing a constant current or by charging the capacitor by a resistor. The RC network can be easily employed to obtain the output pulses. Since the time period is fixed by RC circuit through the capacitor voltage VC, info is the control rectifier circuits to trigger the pulses to SCR by synchronizing with the AC supply frequency. On the other hand, if a synchronization is not achieved, then even for a mid variations in a AC supply frequency, the triggering angle of SCR varies from instant to instant, resulting in the variations of DC output voltage across the loads. To overcome this problem, the supply voltage to UJT circuit is derived from the AC supply, means using a step-down transformers, rectifiers and Zener diodes as shown in the circuit diagram. So this is actual circuit diagrams. We have an AC supply, we have a step-down transformers. This is the diodes or bridge rectifier circuits, and this is the Zener diodes, and we have capacitors, we have BJTs, and we have pulse transformers also here, and this is our SCR, that is anode, cathode and gate terminals. So this is actually the circuits. It looks, and this is load rheostat of 200 ohm or 2.8 amperes. So what are the apparatus required? That is UJT firing modules, resistor, SCR module, auto transformers, isolation transformers, CRO and connecting wires. When we go to the procedure, we have to make the connection as per the given circuit diagram. Switch on power supply to UJT firing circuits. Observe the waveforms of step-down AC voltage output bridge rectifier, voltage across the Zener diodes, capacitors and across the primary of pulses transformers using CRO. By varying R, observe the variations of frequency of triggering pulses at pulse transformers secondary terminals. Connect the output of a pulse transformer to the gate and to a cathode of SCR. By varying R, observe the load voltage, waveforms and voltage across the SCR for different firing angles. So this is the alpha for different values, and we have got the voltage for 157. These are the various voltage we have been obtained. So let's get to make the conductions in real time. So this is actually the graph. This is the AC supply from the transformers, and this is the voltage across the VDC. This is VDC voltage, and this is the voltage across the Zener diodes. These are the voltage across the Zener diodes, and this is the voltage across the capacitors. This is charging and discharging, charging and discharging, charging and discharging, and this is actually the voltage across the SCR. This is the voltage across the SCR where we can see, observe, and this is the alpha, and this is the output voltage. Results: firing of using synchronized UJT relaxation oscillator is observed through the waveforms. So let us see how it can be implemented in the real time by conducting the experiments. I am Anil Kumar TRV, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the UJT turn-on circuit using synchronized relaxation oscillators. So we have to make the connection as per the given circuit diagrams. So after turning on the gates, we need to check what is the waveform across the AC. We need to check what is the waveform across the grids. Then we need to check across the Zener diodes. Then we need to check across the capacitor. Then we need to check across the pulse. Then we need to check across the SCR. Then we need to check across the load. So now let us observe the waveform in the CR across the source, that is AC. So this is a waveform actually. We need to see across the source. Then we need to check across the bridge rectifiers. So this is the waveform across the bridge rectifiers, and this is the waveform across the Zener diodes. This is the waveform across the capacitor that is charging and discharging. Then we need to check across the pulse. So this is the waveform across the pulse. This is the waveform across the pulse, and this is the waveform across the SCR. Then this is the waveform across the load. Thank you.